Today we are talking about one of the most important machines in the world that you have probably never heard of. It has only been sold approximately 140 units and costs $200 million each. There's only one manufacturer of these machines on which all countries worldwide are dependent. If the machine has to be shipped to other countries, it needs 3 Boeing 747, 40 freight containers and 20 trucks. It works so precisely that it could practically hit a coin on Earth with a laser from the moon. I'm talking about the machine that makes it possible to produce the world's most advanced microchips. How it works, why the whole world depends on it, and what conflicts it threatens to cause is the subject of today's video. And with that I say, willkommen to the German Science Guy. I'm Jacob, and in Germany we say, los geht's. Microchips form the basis of our modern world. They can be found everywhere in our everyday lives, in our iPhones, cars, computers, and even in our fridge. The coronavirus pandemic has also shown us how dependent we are on their production. Because supply chains were interrupted and many companies were unable to get hold of these microchips, an estimated 2 to 4 million cars could not be built, and many people waited in vain, for example, for the PS5. For example, me. This is also due to the fact that the production of microchips is limited to a few regions. One country or company in particular has an almost global monopoly on production. This is Taiwan and the company TSMC. This company alone produces around 53% of the semiconductors on the global market. If you look at the latest and most advanced generations of microchips under 10 nanometers, it is even 92%. This makes it one of the only 2 companies besides Samsung that can produce these. Microchips are really highly complex components that consist of integrated circuits, transistors and diodes, which in turn are all made from semiconductors. This is why microchips and semiconductors are often used as synonyms. Microchips later form a central element in the control of electrical appliances. The process of creating a microchip is incredibly complex and technically very demanding. Let me break it down into just a few steps. The basis of every chip is a so-called wafer. These are usually made of silicon, which is melted down and then cut into wafer-thin slices called wafers. In the next step, this wafer is polished and coated with a light-sensitive photoresist. Next, the chip is exposed to light. This exposure process is called photolithography, and I will go into this in more detail in a moment. The structures that are transferred to the wafer determines its later properties. The light is then shown onto the wafer through a mask with these structures and changes the chemistry of the photoresist at the point it hits. The processes are repeated several times until a 3-dimensional structure is created. The wafer now contains many identical chips which can now be cut out individually. The step in which the patterns are printed on the chip is a decisive one, because the more patterns and therefore transistors fit on a board, the more efficient, faster and more energy-saving the chip becomes. This is becoming increasingly important in high-tech devices and robotics. And this actually has to do with the wavelength of light. Light can also be represented as a wave, and the wavelength describes the distance between 2 wave crests. Red light, for example, has a long wavelength, as you can see here on the spectrum. And on the other side is light with a very short wavelength, namely violet or ultraviolet light, or you name it UV light. The wavelength now determines how filigree the structure on the chips can become. This is comparable to a pencil and how thick the lines become. Up to now, a wavelength of 193 nanometers has mostly been used. That is the ultraviolet range. Our eyes can no longer perceive this. So the shorter the wavelength, the more advanced the chip. And this is where the Dutch company ASML comes into play. They research and work with EUV, extremely short wave, like extremely ultraviolet light. And what's really striking is that ASML also has a global monopoly on EUV lithography. In other words, the technology that prints or exposes the chips and makes production possible in the first place. ASML is a company based in Veldhoven and was founded in 1984. ASML is the only company in the world that can produce these machines, and without them, none of the major chip manufacturers such as TSMC or Samsung would be as successful as they are today. Let's take a look at what this company and its machines do and how they differ from the previous one. The basis of the chips is once again a simple silicon wafer. These are also coated again and then exposed, but as you can imagine, the exposure is done with EUV light. And this is because this light does not exist naturally, at least not here on Earth. In space, however, it does. To generate EUV light artificially, a machine about the size of a bus is used. The process starts with one of the most powerful laser systems in the world. This laser has an energy of around 40 million laser pointers. The energy of the laser must now be converted into light with the correct wavelength, namely 13.5 nanometers. This is where tin comes into play, or rather the vaporization of tin. Tiny tin droplets with a diameter of around 24 micrometers and a speed of 70 meters per second are shot from a generator through a gland. The small droplets are then hit twice by a laser pulse. First with a weaker intensity to flatten the droplets like a pancake, and the second laser pulse is extremely intense and vaporizes the droplet, creating a plasma. The plasma generation releases energy in the form of light. And this light is the required EUV light. To generate enough EUV light, the process must repeat it around 50,000 times per second. The right light has now been generated. This must now be fed into the wafer scanner to print the chips. Due to the short wavelengths, this is also an extremely demanding process. First, the light is focused by a parabolic mirror, also known as a solar collector. It is then guided into the correct position via mirrors. The mirror reflector must be extremely smooth. Even unevenness in the nanometers range could destroy the end result. Aiming the light beams at the silicon wafer must be so precise that this is comparable to beaming a laser from the moon to hit a coin on Earth. Now we move on to the exposure. There's a construction plan for each wafer depending on its later function. This is recorded on a kind of mask through which the EUV light is then guided. The mask is called reticle. This is now projected onto the wafer and the light is guided through the free areas in the mask. The mask moves back and forth quickly in order to be able to print the entire wafer. Up to 100 individual chips fit on one wafer. Up to 100 wafers can be provided with their structure per hour. Additional materials such as aluminium, tungsten, copper or silicon compounds must be applied so that the microchip can perform calculations with them. It can take up to 3 months before one wafer is ready. The machines are assembled in dust-free rooms that are 10,000 times cleaner than the outside air. This is because a single speck of dust on a wafer can ruin the entire batch. So you see, the printing of chip blanks using the EUV light is incredibly complex, which is why the machine is described as one of the most complicated devices ever made. Only around 140 of these devices have been sold in the last 10 years, and one machine costs up to $200 million, which is why only 5 major chip manufacturers have been able to afford this technology. The biggest three, TSMC, Samsung and Intel, accounted for almost 84% of ASML's business in 2021. In total, a machine consists of 7 modules and up to 100,000 parts. ASML has 6 production sites in the world. When they are shipped to other countries, it takes 3 Boeing 747, 40 freight containers and 20 trucks. So all other countries are dependent on this Dutch technology and will remain so for the future. ASML is the only company that switched to the development of EUV lithography back in the 1990s, which gives it a huge advantage today. Today, ASML is valued at $250 billion, which makes it more valuable than Intel. According to experts, it would take about a decade for another company to catch up with this technology. This is not only due to the complexity of the technology, but also to ASML's strategy. They have often set up exclusive deals with their more than 800 suppliers, and some of the suppliers have been bought up directly so that no one can tap into the knowledge. And this brings us directly to the big problem of this technology. ASML's monopoly position also harbors great potential for conflict. In particular, a conflict is brewing between the US and China over the high-tech sector. The USA has paved its way into the microchip industry by enabling the chip manufacturing giants Intel and TSMC to build factories there with the help of large subsidies and tax breaks, and this also becomes active on the American market. The US wants to enter the global silicon trade and end its dependency on Asia. In August last year, President Biden signed the so-called CHIPS Act, a $280 billion package as an investment in the chip industry with the aim of breaking China's growing dominance. In addition, chip manufacturers must agree not to sell their latest generation chips to China if they want to benefit from the subsidies. But China is also continuing to invest heavily. This also has to do with Xi Jinping's Made in China 2025 plan, which aims to make China a world leader in several areas, including artificial intelligence. However, both the US and China, like everyone else, are now dependent on ASML in the Netherlands to produce the latest generation of chips. To gain an advantage over China in 2019, the Trump administration successfully persuaded the Dutch government not to export any of the latest EUV machines to China. However, they were still allowed to export the older generation machines that use DUV light. This means that 16% of ASML sales in 2021 still went to China. In new demands under the Biden administration, the export ban is to be extended even further so that the older devices can no longer be sold to China. ASML has been warned by the US that they are dependent on certain components manufactured in the US. If they continue to export to China, the US could consider restricting their export to the Netherlands. Pretty blatant. As things stand today, the Netherlands and the US are still negotiating an extended export ban. ASML is faced with the dilemma of either saying goodbye to its sales in China or taking a stand against the US, which could overshadow its trade relations. And all I can say is, what crazy times are we living in? But how do you feel about the current situation? Are you optimistic that all these disputes, especially between the US and China, will ease, or will they escalate in our lifetime? Write it in the comments and maybe write where are you from, because of course it's interesting for me as a German to see what are the opinions around the world. So see you next time, please subscribe, and I say auf Wiedersehen. So that's goodbye in German.